Welcome, algebra class, to another edition of Mr. Chow Time. Today's episode is going to be on functions, lesson 7. I'm going to give you a warning though. This episode is quite long, as you might be able to see from the time bar at the bottom of your player. You might need to watch this in chunks. I would not expect you to watch this entire thing. I don't know how long it's going to be, but I'm going to guess. Let's say 25 minutes. Let's see how right or wrong I am. Okay, let's start at the beginning with some vocabulary. A function. A function is a relationship between an input and an output. And so if you remember from our previous lesson with domain and range, the domain is the x value that you put into the equation, the independent value, and it gives you an output, a range, which is the y value. Anytime you put in an x, you get a y, right? And as you may just be able to see from, if we wrote this as an equation, this is not going to be for this equation. Let's just write a different one. Y equals 2x plus 1. If we put a value into the x, such as 2 times 2 is 4 plus 1 is 5. Y equals 5 when x equals 2. When x equals 2, y equals 5. So it's going to be written like this, right? It's not possible for the relationship between an input and an output to be different. The relationship is always the same because this is a representation of our relationship, right? This is one form of it. There's no way for us to put a 2 in and then suddenly get a 6 or a 7. If this happened, if we had a domain that linked to more than one output, more than one range value, then it's not a function. Now, can that happen in mathematics? Yes, it can. But then it's no longer a function. And in fact, it wouldn't even really be an equation. But that's a discussion for a different day. So let's take a look at some examples here. Here we have a mapping of domain and ranges. Each one of our domains matches up with a range. It's okay if they match up to the same range. For example, y equals 0x. No matter what you put into x, you're going to get a 0 for y. So the range can just be one number, and all the domains can feed to that, and that's okay. So here's another example of the same kind of idea. A 2 leads to a 4, 4 to a 8. 6 to a 12, and then 8 back to a 4. Crazy. We can have the same range value as long as we don't have another 2 up here that leads to anything other than a 4. Then it's okay. Let's look at some descriptions for different types of functions. So first here we have discrete function. A discrete function is a function with points that are not connected. So if we were to graph a discrete function, it would have points like this that are not connected. A continuous function is a function with a line or curve like this. This would be a continuous function because there are no gaps between the data. Let's take a look at an example. A mountain bike club charges a rental fee of $125 to rent the bike out. For that amount, what you get is cleaning and maintenance of the bike when you return it. Plus, you have to spend $250 an hour to actually rent the bike. So it's $125 to rent. And then $250 per hour. We're going to make a table of possible values. We're going to write a set of data as ordered pairs. Then we're going to graph it. And then we're going to state whether the relation is discrete or continuous. Let's hope I can remember all of these things. I know the first thing is to make a table, so let's start there. At 1 hour, it's going to be 125 plus 250, which is going to be 375. For the second hour, we're just going to add 250 to that, right? So 375 plus 250 5, 2, 1, 6, 25. Oh boy, 625. 3 hours. We'll just add another 250 to that. We're just going to keep these numbers simple instead of jumping around too much. 875. And then we'll add another 250. And this should just be 1,375. Nope. What did I do wrong? Something? Oh, let's just do the math. 1,100. Oh, yeah, I see. Okay. Yep. I made a mistake. It's pretty common. Okay. So here we have our 4 possible values. There are a lot more than that, but there are just 4 of them. If we were to write these as ordered pairs, they would be 1, 375, 2, 625, 3, 875, and 4, 1125. And then if we were to graph these, 1, 2, 3, 4, and then let's just put this up to 1200. So that would be 600, 300, 900, and we'll just leave it there. So 1 and 375 might be about there, 2 and 625, 3 and 875, 4 and 1125. So there we go. What else did I have to do? Oh, I have to check. I forgot. Graph, and then state whether the relationship is discrete or continuous. That's right. So here we go. Is this discrete or continuous? Well, there's gaps in between the data, right? There's these big blank spots, these big gaps. So this is discrete function. Okay. One more example. This might not actually take that long. We'll see. KS is filling a swimming pool after a routine cleaning. So they had to empty the pool. The pool holds 330,000 gallons of water when full and takes 3 hours to fill. I made these numbers up. I'm estimating. If anyone wants to find out the real value and tell me, that would be super swell. I would love that. And I'll bet it takes more than 3 hours to fill. But again, I have no idea. So again, we're going to make a table, but this time we're going to, we're given some values. After 1 hour, 2 hours, and 3 hours, the water is this full. State the domain and range of the relation. Determine if it's a function. Oh, did we do that last time? I don't think we did, but we did write the domain and range in the table. We did not determine if it's a function or not, but it was, because every x value we put in gave us a different y value. Write a set of data as ordered pairs, then graph the data, and then state if it's continuous or discrete again. So let's write these numbers down after, so it's 330,000, takes 3 hours. Okay. I need a blank page. Here we go. Okay, so first we're going to make a table. Should I change the colors up? Yeah, let's change it up. After 1 hour, it's 110,000. After 2 hours, 220,000. After 3 hours, 330,000. Is this a function? It sure is. What's the next question again here? Is it make a graph? Ordered pair? State the domain and range. Okay. Here we go. The domain is 1, 2, 3. The range, is 110,000, 220,000, and oh, geez, 330,000. I get in a hurry sometimes and I make mistakes. Yes, this is a function. Oops, see, I did it again up here. So let's graph this. I'm only actually going to use the top quadrant 1. I'm not even going to draw the other quadrants. 1, 2, 3, and then this is going to be, I'm just going to do this. 1, 2, 3. Okay. This one is going to be filling up like this, right? It's not like after an hour, just boom, going to have 110,000 gallons. It's going to slowly fill up over time. So that means this is a continuous function. Did we get everything? Yeah, we graphed. We didn't write the set of ordered pairs. Oh no. Oh no. 220,000, 330,000. Who skipped this, huh? Thank goodness for skipping, huh? That's the nice thing about YouTube. You don't have to listen and watch me do every little thing.